Hello there. Welcome to section 3 of Unit 4. In this section, we'll be looking at isothermal changes. Let's look at the objectives of this section. At the end of this session, you should be able to define what an isothermal process is, sketch the PV diagram for an isothermal expansion, and derive an equation for the work done by an ideal gas. So, anytime a system performs a work isothermally, we say temperature remains constant. Now, supposing we put an ideal gas in a piston cylinder and allow it to extend quasi-statically at constant temperature. Other parameters change from the initial values, say Pi and Vi, to final Pf and Vf. The process is described as the diagram shown here. The curve is a parabola and ideal gas law with constant T indicates that the equation of the curve is PV equals what? Constant. So here we are going to derive a formula for work done by an ideal gas during an isothermal expansion. And let's start by this formula. Work done equals P change in what? Vn. I explained this one earlier, but let me just go through. We know that our work done is equal to what? Force times what? Distance. So force times distance. And force is related to pressure, as pressure equals force over area, where we can say that force is equal to what? Pressure times what? Area. And we bring our d here. Since we have area and distance, we can add them to become what? Volume. So that at the end we have P equals what? W, or work done, equals what? PV. And right now, because we have our work done to be a change in work done, there's going to be a change in what? In volume too. Now, let's integrate both sides so that at the end, we get the integral of the initial volume to the final volume as what? P dV, which is going to give us, from our ideal gas equation, we know that P is equal to nRT over V. So we can replace our P by what? nRT over V dV. nRT in this expression is a variable constant, so we can bring it outside the integral form and focus on only what? 1 over V, or dV over V. Anytime you integrate 1 over a variable or with respect to a particular variable, we get a natural log. So here we are going to get our final answer as the variable constant that we brought out as the nRT and the natural logarithm of what? Vf over Vi. Let's keep in mind here that in our isothermal change, the internal energy is 0, which means we are going to get our work done. Here is the expression for the first law of thermodynamics. And right now we have our internal energy to be 0, which means that we are going to get our work done to be equal to what? Energy. And it's going to be expressed in terms of nRT in of what? Vf over Vi.